Welcome back. Hopefully you're enjoying a nice tea. I just pressed stop and start, and here we are. We're ready to kick off with the steps you need to get to know your data. So I would say like having a play is really, really important when you're getting to know your data and familiarizing yourself with it. So you have your data set, really trying to understand what each of the variables are, what are their sort of structure, and by that I mean, is it a nominal, ordinal variable, interval, ratio? Even before looking at your data set, if you didn't collect the data set yourself, which many researchers don't do, they use secondary data sets. It's about understanding how that data was collected. If you do collect the data yourself, or you're in a team of researchers that do it, you have a better understanding of what each of the measures mean. But if there's multiple people collecting that data, then you still may not know how others have. Hopefully, it's a standardized system, but errors do happen. And so that's where descriptives are really useful to get a sense of not only your data, but for capturing any errors that may have occurred. So have a play with your data, familiarize yourself with it. Don't be afraid. You really can't break your data. The key principle, I think, is to ensure that you have your raw data file that you don't touch. So that's your raw data file. And then every change you make, you save in a new file. So you have your raw data file, and then if you want to update your data to transform variables or whatnot, you do that in a new file. And so that reflects all the major changes that you're doing to the data set. The reason why that's important is because it allows others to use that raw data file and be able to replicate your work elsewhere. If you're making changes over the raw data file and perhaps you've made an error in your transformation, you may not be able to get that data back. And so that's really, really important to ensure the raw data file is pristine and then you're working across it. So screen and clean your data. It's important to look at your data and make sure all of the variables are within the range that you would expect them to be within. And if there's missing values, it's been coded for the reason as to why there's missing values, or maybe if it isn't, you have a sense of what the level of missingness is. In this course, we don't discuss it in a lot of detail, but there are ways in assessing missingness, and it means different things, whether it's missing at random, missing not at random, or missing completely at random. So if you're interested, I'd encourage you to look up those terms and have a read of what that means for a data set. And there's a whole area of research looking into what the contributions are for how researchers treat data sets with each of these different components. And the critical thing to understand is that if you don't do these steps, if you don't look at your data, if you don't understand your measures and understand the descriptives of them and distributions, then what can often happen is if you jump straight into analyses, you get a lot of confusing results. And a lot of those confusing results can be addressed in some of the basic descriptives that we're addressing now. So if you have a good foundation of I've done my descriptives, I've cleaned the data, I understand the main features of the data, then you can move on to testing your hypothesis to answer your research question. So having that order in place is really, really important to have a robust scientific process. Excellent. So that is the steps to getting to know your data. Really, fundamentally, it's have a play, enjoy your data set. For me, when I have a new data set, sometimes it can take weeks, if not months, to really understand that data. You go through understanding the documentation that's there, looking through the measures. You may identify things that don't make sense, and so you're working out why does it not make sense? Is it because of how the person responded? Is it because of an issue that may have arisen in the encoding of the variable, or perhaps in the storage of the data over time, some changes that weren't tracked? So these are all things that can be revealed in this investigation process. But think of yourself as like a detective and have a play with the data. And all of it contributes to a better analysis. And so in the screening of the data, you want to check first for out of range values. That's probably one of the first things you'll do. You'll look at your measures. You'll try to understand what scale those measures are on, whether it's 0 to 5 or 0 to 7. And then if you start identifying numbers like 99 or 77, or you're looking in your descriptives and it seems like there's a very implausible outlier there, then this is an indicator that something needs to be investigated further. I'm not really sure why people use 999 or 777 or negative 99 in their coding of missing values, but it was typically the way in which people used to. Actually, I do know but I don't know exactly. So the reason I understand it to be is that each of those numbers explain the nature of the missingness. So, for example, someone could respond to your survey and may not feel comfortable providing you with the information. Say, actually, I don't want to let you know. So it's not that it's missing for any reason other than the fact that they are choosing not to provide their information for that measure. Or it could be that they've skipped it for no other reason, that they missed it. And so you can, if you have understanding of these reasons, or maybe they dropped out of your study over time, then you can code those reasons for missing this. And this is where it feeds in again to the missing at random, missing not at random, or completely at random. So, but I don't know what those numbers correspond to. I think everyone makes up their own sort of coding system. And this is where it's really important to have a coding handbook. And so that says exactly what each of your measures mean and how they're coded and how missing values are coded as well. You want to remove or replace errors. So if you identify an error and you know why the error was there, you can replace it, but more often than not, you're removing those errors that are there. Unless you have a really strong rationale of saying, no, I definitely know it's this value and I've corroborated it in these ways, then you can replace, but more often than not, you're removing errors if you have identified them. You want to reverse code items where necessary, and this allows you to ensure that all the items are pointing in the relevant direction, so they're not sort of contradicting one another, and this is important in analyses, what that we'll do later in this course. You want to change not applicable responses to missing data. So if someone didn't encode a response, or they said not applicable, you put NA as their missing data. But again, if you can embed the structure of the reason for the missingness there, that's even better. You want to give the variables sensible names and labels. I'm laughing because I can think of so many data sets that I've worked on where so much time is spent just trying to understand what is this measure. I've tried to get a sense of, like, it doesn't mean exactly what it means. And I've been in situations where I've been working on a measure and someone's told me this is what the measure means. And then when I've worked through the descriptives, I go through the analyses, and I speak to someone else, and they say, actually, it doesn't necessarily mean that. I thought it means this. And then you're looking into the files and trying to work out things. Fundamentally, all of this can be addressed with the coding book, and this is a step that many people don't include in their process. They have their survey, they go collect their data, and then they embed their data there, but they don't create a coding book that says this is the measure, this is what it means, this is how it's coded. And that's really important for people. You want someone to be able to come to your data set, pick it up, and say, I fully understand what I need to do and what each of these measures mean. So that's really important. Sensible names and labels. Dealing with cases with lots of missing values. What do we do when a case has a majority of missing values? And how do we address that? And you want to be documenting and reporting your steps. Now, when it comes to what you do, the reason why it's hard to go in depth here is because there's a whole field of literature around whether you should remove the case completely or whether you should retain the case and just have the missingness there. At the end of the day, irrespective of the approach that's used, the justification is necessary and documentation of what you've done, so that for your analyses, if someone's looking at the data set and they work through the process you've worked through, they should be able to get the same data and get the same results. And so that's where the justification documentation is really key. So that is everything where it comes to screening of data. That's all the steps that you'll need to do. So which statistics can I use? Well, it depends on the level of measurement. This is, again, why I said each of the lectures build, and it's important to understand the previous content for this one. So for the levels of measurement, as a reminder, we have the nominal, ordinal, interval, and ratio. So for nominal, this is where you have categories that are named. And the key distinction is there's no inherent order to those categories. So it could be something like your favorite pet, or it could be your favorite drink. Do you like tea, coffee, or water? All of those there's no inherent order within the structure of those variables. Ordinal is where you have categories that are named, so attributes that are named, and there is an order that could be applied there. So, for example, coming first, second, and third in a race, you could, a friend of mine recently did an ultra marathon, and if you have the positioning of the race, and they say I came second in the race or third in the race, that could be something that people seem as impressive. Firstly, finishing an ultra marathon is impressive in itself, but I don't want to give off the wrong impression. But what I do want to say is that if you're a statistician and someone says I came third, you'd be asking, well, that's an ordinal variable. You get a sense of the order of how you were relative to others, but you don't get a sense of how far you were behind second and first. And so the first person could have finished in 12 hours and then 20 hours and then 30 hours, right? Or it could have been 12 hours and a minute, 12 hours and 2 minutes, 12 hours and 3 minutes, right? So the positioning remains the same, but the difference between those isn't. And so ordinal allows you to understand that there's an order to those, but it doesn't give you a sense of what the difference is between those categories. That's where intervals come in. So that's where the distance between the categories is meaningful. And so when you're looking at the interval data, you're saying, well, is the difference between these groups, is it meaningful? For ratio, it's the same as interval, but you have a meaningful zero as well, a true zero. So this can be something like height or age or weight, where the zero has a meaningful value and allows you to create ratios, right? So each level, so you have nominal, ordinal, interval, and ratio, they can have properties of the level that came before, plus some more. So when you have a ratio variable, you can essentially code that ratio variable to interval, to ordinal, and nominal. But you can't, if you have a nominal variable, you can't code up. So whenever, as a researcher, you're collecting data, you need to be asking yourself, even at this stage, how do I want to code this measure? In what ways do I want to code this measure? Do I want it to be nominal or ordinal for my analyses, or would it be better to have it as ratio? And sometimes you may think it would be better to collect everything as ratio, and you're right, it would be, but in some instances there may not be a need to do that. And so if you think that having the categories is useful for your analyses and that's all you need, then maybe that's all that you need to collect as well. So pay attention to the level of measurement of your data. Level of measurement determines what kind of descriptive statistics and graph and inferential statistics you can use. So again, really important to know what the level of measurement is of your data so that you're able to understand what statistics you can use moving forward. Excellent. So let's talk about level of measurement in the context of these two words called parametric and non-parametric. So essentially, when you have a categorical or ordinal dependent variable, this is where it's a non-parametric distribution, non-parametric measure. For interval and ratio dependent variable, you need to check the distribution. If the distribution is a normal distribution, this is what's termed as parametric. But if the distribution is non-normal, it's non-parametric. So the real key takeaways from this slide is thinking about, we have our levels of measurement and they can be grouped as parametric or non-parametric. If it's nominal or ordinal, it's going to be non-parametric. If it's interval or ratio, well, it depends on the distribution. So you check the distribution. If it's normal, then it's parametric. If it's non-normal, it's non-parametric. So what does this mean, parametric and non-parametric, and why is it important? Well, parametric statistics are estimates. It estimates the parameters of a population based on a normal distribution, right? That's why you have to check if the distribution is normal for it to be parametric. And this allows you to do univariate statistics, so mean, standard deviation, skewness, and kurtosis. It allows bivariate analyses like correlations, t-tests, and linear regressions. And then multivariate analyses as well, like multiple linear regressions and analyses of variance. Now, for non-parametric statistics, they don't assume sampling from a population which is normally distributed. So you can use things like medians and frequencies for univariate variables, For variables, you can do Spearman's correlation or chi-square tests. So again, identifying what the variable is, what the level of measurement, the distribution, if it's interval or ratio, and identifying whether it's parametric or non-parametric. That's the flow of thought that you need to be having, because that will lead you to understand what can I do with this measure in terms of analyses. We'll talk about some of these analyses in a lot more detail in this unit, but for now, just understand that not only the level of measurement, but whether it's parametric or non-parametric determines the type of analyses that you can do. So the difference really is parametric statistics are more powerful and more sensitive to your data. There's more assumptions that need to be met, because those assumptions are that it meets the assumptions of a normal distribution. And it's vulnerable to violations of assumptions, so it's less robust in those ways. Non-parametric statistics, they're less powerful and less sensitive to detect effects. There's fewer assumptions, so they do not assume a normal distribution, so fewer assumptions to meet. And they're less vulnerable to assumption violations. So in that regard, they're more robust than parametric statistics. So how many variables are you working on? If it's one, it's called univariate. If it's two, it's called bivariate. So again, statistics is a language. The more you can view it through this lens of it being a language, the more you'll understand that if you understand the words and the terminology, the better you'll get a sense of the culture of statistics. And so when we talk about univariate and bivariate, this relates to one variable, or bi as in two variables. And so when you have one variable, you can look at its mean, its median, its mode. You can plot a histogram or a bar chart. For a bivariate variable where you have two, you can look at correlations. You can compare the means through a t-test. You could do scatter plots or clustered bar charts. If it's more than two and you have multivariate variables, you can do reliability analyses, factor analyses, and multiple linear regressions. So these are all the different ways in which you could do analyses and sort of plot those analyses as well. So for univariate descriptive statistics, what do you want to describe about the data? So it could be measures of central tendency, which are frequency of mode, median, and mean. So frequencies, mode, median, and mean. And so that gives you a sense of your data and their distribution. And then you could also look at the distribution of the data itself. So the central tendency gives you a sense of the values and how common they are, but the distribution gives you a sense of their spread, the dispersion of the data. So you have minimum and maximum values, range, percentiles, variance, and standard deviations. And the shape is skewness and kurtosis. We're going to go through these in a lot more detail, but right now what I want you to take away is what you can describe from univariate statistics. So you're trying to get a sense of, okay, what is probably the middle value or the most frequent value or the median value, and that's central tendency, or the shape of your data, the dispersion, the spread of your data, and the overall shape. Is it really central and peaked, or is it really flat as well? And we'll cover this in more detail. And so central tendency is statistics which represent the center of the frequency distribution. So you have your distribution. Hopefully these hand gestures are making sense. So you've got your distribution. You can look up a normal distribution and get a sense. And if you want to know an understanding of the middle, which is where most of the data is in a normal distribution, you're looking at the mode, which is the most frequent data point, the median, which is the middle, so the 50th percentile, so the middle score if scores are arranged from smallest to largest, or the mean, which is most commonly used for understanding averages. So if I had all these values, what would the average of this be? And how do you know which one you use? Well, it really depends on your type of data, the level of measurement, and the shape of your distribution, especially the skewness. So we'll look at scenarios later on of what happens when the bulk of the data is actually shifted, and then you have a long tail on either end. And what does that mean for the mode, median, and mean? And so sometimes reporting more than one might be appropriate. And so here's a good summary of central tendencies and understanding when to use them. So for nominal, essentially mode, frequency, and percentages are useful. Median and mean isn't useful in nominal because, again, it's a category. Ordinal, again, median, mean, it's not often useful. Median can be if it's meaningful in some cases, if you have that order and there's sufficient meaning between the gaps and the median is meaningful. But of course, for all of them, you can use mode, frequency, and percentages. For ratio, if it's meaningful, you can use the mode, frequency, and percentages, but typically you'd be using something like the mean or the median to describe a ratio measure, similar to interval. But again, you could use mode, frequency, and percentages if you wish for an interval measure. But these are the ones that the mean you wouldn't be able to use for ordinal and nominal. So this is a good example or a table to sort of take away. So you could look at this table and get a sense, but I guess once you understand what each of the level of measurements are, nominal, ordinal, interval, ratio, you would get a good understanding as well of whether or not you can use the mean. For example, if your ratios are dog, cat, and bird, you wouldn't be able to get an average of those categories, right? So inherently, by understanding what a nominal variable is, you'll be able to work out this table as a function of it, whether or not you can use it. Excellent. So that is measures of central tendency. What we'll do is we'll stop there, and then we'll go into the mode and then what is the mode and progress from there. So you hopefully have a good sense of central tendency and univariate and bivariate descriptive statistics and when to use them and what you can use. We'll move on into a lot more detail about each of these things in the next video. Have a break and we'll come back in a moment. I'll see you in a bit.